Alright, so this video is an answer key for the Grassville math activity from last week. If you were absent, it's designed to help explain the activity that students completed, and for those that were in class, it's an opportunity for you to see how some of the problems were completed if you were not successful in completing any of the problems from that activity. So problem number one, screen one, or problem one, and problem three are very similar to each other. Again, all these problems are coming from the handout that was distributed last week. And so our rules for simplifying fractions are no different, at least at this point, than we learned in elementary school. So when we look at fractions such as this with numbers, we have a 16 and 28. They both share a common factor of 4, so if I remove the 4 from here and from here, I'll end up with 4 sevenths. If I put the 28 on top of the 16, it will actually simplify that for me. We learned exponent rules. You did that in Algebra 1 as well as this year in Algebra 2. If you put the two pieces on top of each other, they're going to subtract the exponents. This is a 2 and this is a 1. So 2 minus 1 is 1. So the final answer is 4p over 7. In this problem here, which I had quite a few conversations with students, if I stick the 2 on top of the 4, you would think that negative 4 divided by negative 2 would be 2, but it will not simplify that. Or if I stick this here, 2 divided by negative 2, you think that would be like a negative 1, or you think I could do like r minus, strike the exponents, and that become r is equal to 0 for an exponent. And it doesn't do that. And the reason why is because r minus 2 actually represents a single number. So when they're separate, such as this first one here, the value of p is a p. If I go down to the third problem, n is an n, and this is also n, I'm just cubing it. But here the r minus 2 actually represents some number. So if I let r be 5, then that means r minus 2 is 3. And so the only way to get rid of a 3 is with another value of 3. So if I look at the numerator, both the 2 and the 4 share a factor of 2, and if I stick the 2 on top of the 4, it will actually factor for me, and in doing so I have an r minus 2 over r minus 2. So if r is 5 again, this is 3, and this is 3, and 3 divided by 3 is 1. Or I let r be 7, this becomes 5, and this becomes 5, so 5 divided by 5 is again 1. So when in this form, if I put r minus 2 on top of the expression of r minus 2, it will actually simplify that, because both those our expressions will always equal the same number. And then so under division, we're going to get an answer of 1. Now there is one number that doesn't work there, and we'll talk more about domain restrictions later, but for right now, just understand that the r minus 2 for every value but 1, it's workable, but there is a place where we have a division issue. So again, we'll talk about that at a later time. So this problem here, again, we can take 15 divided by 30. So I'll put these on top of each other, I'll get half. And then this is a 1 and a 3, so if I put the ends on top of each other, it's going to do 1 minus 3, which is negative 2. And we want the exponents to be positive, so that means the ends belong in the denominator. So it becomes 1 over 2n squared. So here, one of the comments I made last week is that if you see like an x minus 4, that's kind of a hint that if I want to be able to simplify this fraction, I need to look for another x minus 4 expression. So if I put the 3 on top of the 12, it will factor out the 3. And this is getting closer to that x minus 4. This has 2 x's, and this has a single x. So if I put the x on top of each other, it will actually factor out an x, because both sides of the subtraction sign shares an x. And in doing that, now I have an x minus 4 over x minus 4 expression. So any value for x will work here, and these two expressions, every value for x will work here with the exception of 1, and that actually is 4, because 4 minus 4 is 0. We can't do division by 0. Other than 4, every number will work here, and this expression of x minus 4 and this one will equal the same number. So I put the x minus 4s on top of each other, that makes a 1. So in here I see a v minus 5, And so hopefully, again, there's a v minus 5 in this one. I would recommend as you're working through these problems with quadratics, you think about factoring it first, so you have some idea of what you're going to make the factors to be. So in this problem here, v minus 5 and v minus 5 will give me this answer. So under formulas, there is it says manually factor a quadratic. If I left click on this x squared plus bx and slide it with my left mouse button down up to this, it will actually separate it for me. And then if I click on the square, I can type in -5, and if I click on the square again, replace that with square root of -5. You need to add, as we've been doing in class, you need to do the addition of a negative, make that subtraction sign. And then again, we have v minus 5 over v minus 5. So if I put one on top of the other, that's going to be a value of 1. So I end up with 1 over v minus 5. Again, v can't be 5 here because 5 minus 5 is 0, and 1 divided by 0 is not doable. This time we have 2 quadratics to do. So again, I'm going to use that formula tool twice. So again, be thinking about what numbers are going to work here. And we do want to get suggest that you factor them first so you know what expressions you're going to get from these before you actually use the tool. So under the formula tool, I'm going to go ahead and do the top one. I'm going to intentionally do these incorrectly because I want you to see that, for example, if I would have chosen if I choose the wrong factors here, so let's say, for example, I do this here, and it looks like I get a v minus 3 or v minus 3, and I put these on top of each other, they factor out, but all of a sudden, there's no green rectangle. If that happens, that's an indication that you have factored the quadratics incorrectly, and so you need to go back to where you were and try to figure out what factors actually will give me those answers. So again, I'm going to do this again, this time correctly. So it's v minus 10. V is negative 10 here, and this is positive 3. And then I use the formula again to factor. We have v minus 8, so negative 8 here, and positive 3 here. So before I had v minus 8, v minus 3, v minus 3, they're actually addition problems. And this time, when I do v plus 3 divided by itself, that's a 1, I have 1, I do get the correct answer. So again, trying to figure out what numbers or what factors to choose here. So using the to manually do this, so v minus 9 and v minus 2. Oops. For the denominator, if I factor it, I get v plus 4 and v minus 2. So if I put x is not v, x is, so x minus 2 over x minus 2, and final answer is x plus 9 over x plus 4. This one here, we don't have a quadratic, but there's a 4 here and a 4 here, so there definitely is a common factor of 4. So if I put the 4s on top of each other, it will factor out the 4. And the 6 and the 20 both share a common factor of 2. So if I put the 6 on top of the 20, it'll factor out my factor of 2. So the n minus 1 and the 3x minus 10, if I put one on top of the other, for example, if you do that, it's actually not going to do anything in terms of simplifying it. It'll just put this 3x minus 10 to a negative 1. So again, you can't just put a subtraction problem on top of another one, expect that that's going to simplify it. They got to be the same thing. but I can do 4 divided by 2, which is 2. Problem 9. This one requires a lot of, I call it prep work, to get the problem set up to be able to simplify. For example, I notice the 6 and 42, they both share a common factor of 6, so I can remove the 6 from both terms. They both share 2 v's, so if I put the v cubed on top of v squared, it will factor out the 2 v's. So I end up with 6 v squared and then v plus 7. So hopefully down here I got an even number, potentially, maybe a v, and hopefully a v plus 7. When simplifying the denominator, if I put the 2 on top of 26, it only factored out the 2 for the first 2 terms. If I put the 2 on top of the 84, it will now factor out the 2 from all 3 terms. So you have to actually manually do that for all 3 terms for it to factor out the 2. So if you only do it for 2 terms, it won't do anything to the third. So I do have an even number here and here, so that's going to simplify the 6 and the 2. I see a v here, but no v here, so I can't factor out the v like I did here. But with this quadratic, hopefully there's a v plus 7 in there. So again, if I factor this, I get v plus 7. And this one actually is v plus 6. So I can do 6 divided by 2, which is 3. And I can do v plus 7 divided by v plus 7, which is 1. And end up with 3v squared over v plus 6. And then our last problem, I'm going to start with the denominator since there are only 2 terms. 8 and 64 have a common factor, so I can remove that and get 8 times v plus 8. Up here I notice that all 3 of these numbers are even, so I'm going to factor out the 2 out of the 10 and out of the 48. So I end up with this 2 times this quadratic. Hopefully in this quadratic that one of the factors is v plus 8. That will allow for us to factor the v plus 8 over v plus 8. So in our formulas, v plus 8 is one of the factors, and the other one is v minus 3, so I'll put a negative 3 here. So when I add the 3 and the negative 3 and the 8, that's 5. That was the middle term. And if I take and multiply it 2, that's negative 24. That was the c term of that quadratic. So I put the v plus 8 on top of itself. That's 1. I put the 8 on top of the 2, or the 2 on top of the 8, and I get 1/4. So final answer is v minus 3 all over 4. So hopefully that discussion is helpful for those of you who may have been absent and maybe be working on the next activity. If you didn't complete this one, I would recommend after watching the video, if you've not completed, go back and work on the problems from the original activity, see if you can complete those. And for those of you that didn't complete the activity, hopefully the video was helpful in looking at problems that you were not able to figure out.